Hey, it's Eddie here with FlexArm. We just had an end user reach out to us looking for a better tapping solution to help reduce production time without sacrificing quality. Now, they manufacture custom aluminum extrusions of all shapes and sizes and currently tap these parts in the CNC. Now, before they invest in our solution, they wanted to see if the FlexArm could truly help speed up their operations. So to demonstrate the capability, we tapped their part using an A32 tap and paired it with our A32 pneumatic tapping arm. The FlexArm was able to quickly and easily tap all the holes in the extrusion in much less time than it would have taken in their expensive CNC. Their current tapping process takes minutes to complete, and with some parts having up to 18 holes, the extra time is absolutely killing their productivity. However, the FlexArm decreased downtime significantly by tapping the part in just a matter of seconds. So if you're looking to free up your CNC, speed up operations, and you're ready to start flexing on your competition, give us a call at 1-800-837-2503.
All right, everybody, today we're going to go over the Helicoil tapping arm. I'm going to show you guys a demonstration and a little bit about what makes this arm such a great unit. We'll start with the assembled arm here. So you'll see we have our 1500 RPM Helicoil motor, our filtered lubricator with a built-in regulator. That way I can dial my PSI for my front end assembly depending on the size helicoil that I'm going to be running. So you'll see these arms are nicely equipped with a roll that we can put right on the arm, and we put the helicoils in a strip feed here so that we can do fast, easy helicoil insertion for any of your thread repair. All right, so starting with the motor, you'll see this is the Helicoil motor, 1500 RPM motor that we use for driving the helicoils. Each motor comes with a small adapter, or a large adapter, or a small adapter. So these adapters are used as bridges for different sizes of front end assemblies. So in this case, for the large, or for the small adapter, we're going anywhere from, this is for the 256 to 1/4 inch front end assembly. And then this is our large adapter for 5/16 to 1/2 inch. And this adapter goes onto the motor, and this is what is used to bridge the motor and the front end assembly. Everything's left-handed thread. So we put that on, and now the motor's ready to receive a front end assembly. The other component I'll show you, it's a friction clutch. So the friction clutch is used for our small adapter for your small helicoils. So anything from 256 to 440 is what I'm going to use or recommend the friction clutch for. In the small adapter, we pull out the stock insert and we put in the friction clutch. And this is just really going to help us with those smaller holes to limit the torque and stop us from damaging our front end assembly or the threads that we're repairing. So next you'll see, this is an example of a front end assembly. This is a 3/8 16 front end assembly. This is our nozzle. This is the mandrel. And each one comes with a bag of cushions and spacers. So we use, the cushion goes into the large adapter, and it helps cushion your mandrel, your driver. And then different spacers here for setting my depth. So that way, another advantage with the arm is you can set the depth. So that way I can drive the helicoil to the proper depth every single time. And I'm setting that here with these spacers, and I'm putting it on my mandrel. So I'll put one of these on here as an example. And we'd place one of our cushions inside the large adapter here. And we place the front assembly on. And again, left-handed threads. And that's about it. So now we're ready. So today what I'll show you, I've got my arm set up here to drive quarter 20 helicoils on this strip feed. And we've got a nice aluminum piece here ready to place those. This is a blind hole. We're going to drive them to the bottom. Depth's already set. automatically reverse. So it automatically drives it to depth and then automatically reverses. So you'll hear the motor has a hissing. That's normal. It's designed that way. First things first, I'm going to set my pressure here. So something to note is every front end assembly has a desired PSI to set your air pressure correctly for the helicoil. So in this case, it's set for 45 PSI. So I'm going to take my regulator, I'm going to adjust my pressure, set it to 45, lock it in, and now we're ready to drive the helicoil. So I have everything set up here on the strip feed knob. So I'm just going to simply line the arm up over the hole. I'm not going to fight it. I'm going to let it do the work. So we'll drive it on down. Automatically reverse. Now we have a perfectly placed helicoil. And that's all I have for today. If you need more information on our helicoil FlexArm, give us a call or shoot us an email. You can visit our website at flexmachinetools.com or 800-837-2503. And we look forward to helping you out with your next thread repair job. Thank you.
Hey guys, it's Tyler here from FlexArm. We recently had a prospect reach out to us looking for a better tapping solution. National Enclosure Company out of Michigan is a nationally ranked advanced facade contractor, and they were looking for an efficient way to tap the end of an aluminum extrusion. They're currently outsourcing these parts or tapping them in-house with a hand drill. The problem with outsourcing is that they have no control over the quality or consistency of the parts, and their volume is way too high to continue the slow process of tapping with a hand drill. I told them to send some parts in and we could run a tap test on the FlexArm. The extrusion needs 2 inches of total thread depth and needs to accept a set screw in the end, so we fixtured the part horizontally and decided to go with the GHM18 hydraulic unit. This has the multi-positional head which will allow the operator to tap horizontally and easily reach their desired thread depth. One issue that we ran into in this tap test was chip evacuation. The end user supplied us with a straight flute pulley tap, but due to this horizontal positioning, the chips had nowhere to go. We swapped the tap with a 3-flute spiral point tap, which helped us pull the chips out of the part. The tap test was a success, and the FlexArm had no problem tapping the part to the correct depth. So if you're experiencing any similar problems or just looking for a better way to speed up your tapping process, go ahead and give us a call at 1-800-837-2503.
You like what you see? Now what if I told you you didn't have to own a FlexArm to enjoy one of our carts or tables? Now, even though they're primarily made for tapping, let's see what else they can do. You can also use it as a mobile workbench. The 200 tapped holes make fixturing a breeze. You can use it to haul raw materials. You can use it to haul finished parts. Use it at your next cocktail party. Use it for an arm wrestling table. You can even use it to haul your trash and recycling. Really? And with a weight capacity of up to 1,000 pounds, you can haul whatever your heart desires. Need a place to put your TV? FlexArm mobile cart. Need a dining table for your date night in?
Wait, this isn't a table?
FlexArm mobile cart. Trying to hide from your pesky boss? FlexArm mobile cart. And they're so durable, you'll even be able to pass it off to your grandson. And just in case you need something a little bigger than our mobile carts, check out our line of coolant troughs and tables that are just as versatile. What's up, everybody? This is Eddie from FlexArm, and we are coming at you live from our beautiful facility here in Wapak, Ohio, via YouTube live stream and all the socials. Now, we have an amazing demo set up for you today. We're going to be doing some tapping in some plasma cut plates, some laser cut plates, and even water jet plates, just to prove how strong and versatile our hydraulic as well as our pneumatic tapping arms can be. So before we get started, let's lay out a couple housekeeping items. As you will see on the side of your screen, there's a chat section, and we highly encourage each and every one of you to be as engaged as possible. If you have questions or comments, please feel free to drop those in the chat section, and we'll be pulling those up live and answering them in real time. Also, you notice on the bottom of your screen there is a subscribe button. Please hit that subscribe button, hit that bell so we can keep you up to date with all the notifications, and give us a huge thumbs up. We greatly appreciate it. So joining us, oh, we already got a thumbs up. Look at that. That's awesome. So that being said, we have a very special guest with us today. I'd like to introduce my man, Jason from Gladwin. Jason, how you doing today, man?
Pretty good. How are you?
No, it's an awesome day to do some plasma, laser, and water jet cutting. So with those who may not be as familiar with Gladwin, can you tell me a little bit about what you do there with Gladwin?
So I've been in metal fab for about 28 plus years now. The last 4 years I've been with Gladwin. For the last 12 years I've actually been teaching. I'm their applications instructor. I've been teaching their forming fundamentals classes. I also do some on-site training and that type of stuff. We saw obviously all the different metal fab equipments.
Right on, right. Looks like we got a little bit of background music. It's going to be interesting. So no worries, we'll get that taken care of. So, hey, I appreciate that. Thank you so much for joining us, and I'm looking forward to picking your brain a little bit on some of these applications. So what we're going to be doing first is we're going to be setting up on our GH45 right here behind me. I've got my man Logan who's going to be joining us, and we're going to be cutting and starting with a laser plate. And all these plates, we've got to give a big shout out to our good friends Tiemans over there in New Bremen. Thank you so much. You are awesome. So Logan, tell us a little bit about what we got going on. What are we doing today?
Yeah, so we're going to be, like he said, we're going to be cutting in some material here, some hot rolled steel, and we're going to show the differences here on parts cut by a laser, by a plasma, and then also by a water jet. But to start off here, we're going to be tapping some M30 holes and some 3/4 inch holes. And I'll get this fixtured up here.
And while he's getting that fixtured, Jason, can you tell us a little bit, for those who may not be as familiar with laser cutting, kind of what goes in behind it and what really makes these holes the way that they are?
Well, there's a couple different styles of lasers out there. There's the CO2 laser that has been around for a long time. Pretty much generates a beam, bounces it off mirrors, and cuts your parts out on the laser. More popular now is obviously the fiber optic laser. This delivers the beam a little differently through a fiber optic cable, and they're just extremely fast now compared to the old CO2s.
There we go, spoken like a true expert. I appreciate it. Logan, you ready and set up, my man?
Yep, so we'll start here with the 3/4 inch tap, and we're gonna run this in our gear 1. You know, to be honest with you, we did some tests here in the gear 2, but because this material hardens a little bit, you know, we had to drop it into gear 1 because it takes a little more torque to tap these holes. So I'm going to tap this here really quick, and then once I run through this, Jason, maybe you can tell us a little more as to what you need to take into account when you are tapping these holes with maybe the holes coming out undersized, or the material hardening, or maybe them not being uniform, that you had to take into account when you know you need to tap these holes. So I'll run this here real quick. So as you can see, that came out beautifully. So as I'm changing out the size here, Jason, maybe you can touch on a couple of those things I just mentioned.
Sure. So when you're laser cutting holes, obviously in a 3/4 inch plate, whether it be a laser or plasma or whatever, couple things that can be happening. For one, you're going to get a heat affected zone. That's where the beam's going, cutting the material, heating up the plate pretty good. The other issue you can run into is, of course, the hole may not perfectly be round, depending on how fast you cut it. So there may be times where you do have to slow the laser down or speed it up or whatever. There's no magic bullet to that. Another thing that can happen when you get into heavier plate is you might have to do what's called like a beam offset. So maybe I drew a 5/8 round hole in a part. It's very important for the operators to make sure that that's what they're actually getting when it comes to a tapped hole or a hole you're going to put a PEM in or whatever on a laser plasma. And a lot of that has to do with the size of the beam that's actually being delivered. So I may have drew the hole perfectly, and it shows the inside line of the path to cut the hole. But now if my beam width varied, that may either make my hole smaller or bigger. So those are things you got to kind of watch out for on those types of machines when you have critical holes like this for tapping. So.
Well, there you go. Well, good insight, man. Hey, Logan, you ready to take a step up?
Sure am. Yeah.
Let's do it.
This is going to be M30. Same in a laser cut hole here. We'll run it real quick. Again, easy, cuts through it well. We'll give you a quick look here at what this looks like. And this demo, really the purpose of this is to show, here you go, you can show it to the screen, that a hole to be tapped doesn't necessarily have to be machined. It can be cut with a laser or a plasma or a water jet. Just because, you know, that maybe there's some specific tolerances as far as the threads go, that it doesn't have to be machined to reach those. And the idea is, you know, the FlexArm has enough torque to even cut through some of these holes that come out not quite uniform. As you'll see here in these plasma cut parts, the backside of these holes, if you want to show them this, Eddie, are not perfectly round. If you want to flip it too, that'll show the backside. So a lot of times it's difficult to get a tap actually to go through this well. Just because in some parts it's cutting more material than others. And so if you're tapping this by hand, it's especially difficult because you have to apply more force in some areas than others. But we'll show you here how easy it is to tap this with a FlexArm.
There you go. And while Logan's getting this set up, Isaac, do we have any questions in the stream that we can pull up and answer? All right, Tyler Albert, my man, what is the thickest material a plasma table can cut a hole in steel before the hole becomes too oblong? And then how thick of material can the FlexArm tap in the 3/4 10 tool? So I think the first question would be for you, Jason. Can you tackle that one?
I'm not totally sure on the plasma table side what they can go up to. A lot of the lasers will go up to 3/4, 1 inch. I'm not exactly sure what on the plasma side.
Yeah, no worries, no worries. And how thick of, we can pull that stream, what's it, how thick of material? Can you pull that up, Isaac? I'm trying to see when you're going from screen. Okay, how thick of material can the FlexArm tap with a 3/4 10 tool? Logan, you want to tackle that, my man?
Yeah, as far as thickness goes, there really isn't a limit. It comes down to tooling at that point. The tap actually will pull itself through this hole. So there's enough torque, and especially with these hydraulic units, the torque output is really consistent just due to the hydraulic components. And as long as your tap and tooling is long enough to continue tapping through that hole, and there's good enough chip evacuation, depending on if it's a through or blind hole, thickness should not be a problem at that point.
There we go. Yeah, good question, Tyler. Appreciate it. Well, we got another one. Josh here. How does this affect the tap's life?
Yeah, so that's a good question too. So tap life, you know, especially with like a plasma hole like this, with it not being perfectly round, yeah, it's going to be a little harder on the tap than it would be if it was machined and the hole was a tighter tolerance. But we use you know, lubricant. As long as you're using good lubricant, it'll help. And then in addition to our clutch that's actually built into these tap holders as well, it will ratchet out before it would snap or the torque would be too high to cause any damage to it. So that's a safety net too. But we work really closely with OSG. They are the experts in the tapping department as far as the tooling goes, and they are happy to answer any questions. If you'd like us to have somebody reach out to you, we have a lot of contacts and we're happy to help.
Yeah,
so
awesome, man. No, it's awesome. Hey, great questions. And for those in the comments section, please feel free. Keep those comments up. Keep the questions up. And then if you can, tell us where you're tuning in from. We like to see, you know, who we're interacting with. So, Logan, you ready to tap this plasma plate?
Sure are, yeah. So
we
we're
go.
gonna run this 3/4 inch tap again, but now this is plasma. And like you saw, the holes are not quite so uniform. But we'll see here that the FlexArm takes care of it, no sweat.
Beautiful. Beautiful.
And as you can see, this will give you the capabilities like a fab shop that maybe doesn't do a lot of their tapping processes in-house. Maybe they sub it out, particularly because the last thing that you want on a part that is basically almost done except for the tapping cycle is to ruin it and have to scrap the part, rework it, or anything along those lines. And this just gives you the capability to keep it in-house and do it in-house.
Right on. So what are we getting ready to do right now? Is that M30?
Yep, this is M30. Again, plasma cut. So as you can hear that, it growled just a little bit, and that's because, this hole, it hardens a little bit, and some of these did come in, a little bit undersized. So I know that could be potentially and also a problem with the laser too. Jason, do you want to talk about some of the issues with undersizing holes and how to maybe mitigate that? I know you maybe touched on it a little bit, but how that could affect, being able to tap it and processes afterwards?
So obviously, as you know, there's a lot of variables involved here. Machine, age of the machine, material thickness, hole size that you're trying to put in, thicker material. Bottom line is you probably can dial in just about any machine. You just might have to oversize the hole a little bit, draw it a little bigger to have it come out right. You may have to, like I said, either slow down or speed up the cut to get the roundness working better for you. So no matter what vintage machine or what you're doing, you can dial it in. I just wouldn't suggest cutting 1,000 holes and then trying to tap one to see if it's right. So
sure.
But yeah, I mean, you're experiencing on these machines, you're experiencing some cut taper. I don't know if I mentioned, so the top of the hole is going to be a little larger as the beam kind of diverts a little bit than the bottom of the hole, and I think you saw that best on the plasma plate. There's just a lot going on there, but it's not something you can't overcome. It's just you gotta take the time to do it. And don't get me wrong, 9 out of 10 times you're gonna cut something and you're gonna be able to tap it just fine. It's just when you run into these situations where, so yeah, obviously a little undersized is not ideal. In a lot of cases you're gonna have maybe plus 5 thousandths on the hole and minus 1. So, and you guys would maybe know better that what you're looking for in a tolerance on a tapped hole, but under is not good in a lot of cases. So
Sure.
Yeah. Well, right on. Well, no, good insight. So, I mean, really good examples of working with multiple types of plates on our hydraulic arms. So, Logan, what do we have in store for the pneumatic arms?
Yeah, so this model specifically is our smallest pneumatic unit, the A32, and this has a capacity of 9/16 in mild steel. Now, that capacity may vary depending on, like we've mentioned before, the holes being hardened a little bit, are coming in a little bit undersized, or not quite as uniform. But we'll show you here that it's still no problem for the FlexArm, even their smaller pneumatic units. So we're going to be tapping 3/8 holes and 1/4 inch holes here on these plates, laser, plasma, and we're actually going to be doing a water jet as well.
And we got a question up here. Matt, my man, are there any limitations to quality of plasma cut? And would tapping an ISO 6 low quality air plasma, and is there a post-plasma process to help hone holes the FlexArm can help with?
Yeah, so that's a good question. And obviously there are some limitations as far as quality of hole. Now, if the hole comes out really poorly and it's not round at all, I would say that would probably mean, if you're trying to get a uniform hole and it's a fairly decent size, maybe you should look at, another plasma if you're planning on tapping those holes and it's important. But what you can do, if a hole does come out not quite perfect, you can ream it. You can ream that hole and it would then come out a little more uniform to be able to tap it. No worries on that. But here I'll show you that we will actually be able to use this little tool here to pop in and chamfer these holes before we tap them. So, in reference to the reamer, you can do more than just ream hole or tap holes with the FlexArm. You can chamfer it like I just showed you, and then ream it to get a closer tolerance that you had. So Eddie, it looks like we got another question here as well.
Oh, Tyler, man, with the questions, I like it. So what is the smallest size tap you can thread with the FlexArm in a plasma cut hole? So we'll start there. So what's the smallest size tap that we can thread with the FlexArm on the plasma cut?
Yeah, so, as long as the hole, is fairly uniform, you could tap it almost as small as you would need to, odd 80 even, as long as you're careful and that material didn't harden up too much. But again, if it did, we've got the built-in clutch here, so the tap would ratchet out before it would cause any tap breakage. I would say it's pretty rare to tap that small of hole anyways, especially cutting it with a plasma or a laser, because it may not even be possible. But the FlexArm, as far as going down that small, does not have a limitation at that point. It'd be a limitation on the machine that you're cutting the holes with.
Now, what about that quarter 20 then? What about that? It says, could it handle a quarter 20 UNC?
Yeah, absolutely. So we're actually going to show that to you right now.
There we
this
go.
Specifically is laser, but we'll show that plasma here in just a second.
There you go. Thanks, Tyler. Appreciate your questions, man.
So right here is your quarter 20. And as you can see, no problem with this one. We'll swap this out, quick change chuck, boom. And we'll go to a 3/8. Get some lube on there. There you go. So yeah, I'll get this set up here. We'll show you those plasmas that the plasma you were just talking about.
Yeah, we'll check those out. We'll pull them up on the HD camera. And I got a question for you, Jason. So where do you feel in specific situations, where do lasers perform the best? Whether it's materials, types of holes, what are your thoughts, man?
I mean, lasers are just a very quick way to cut a very high tolerance part, something that needs to be just right on. I don't know. They do a great job on just about everything, I would say.
There you go, right on. As we can see on our HD camera here, the way that the FlexArm ripped right through, see some of the thread quality that we're looking at here. Looks pretty stinking good for a laser plate. Right on. Logan, you all set up for the plasma?
I'm ready.
Good deal. Hey, Jason, thanks for that insight. Logan, what's going on next, man?
Yeah, so in reference to Tyler's question here, we are going to tap quarter 20 holes now in plasma cut holes. So I'll run this here for you. And as you can see too here, I can bounce from one hole to the next, and that's part of the appeal of the FlexArm. There's no need to refixture this part under the head of a drill press or another machine that you require to be refixturing it for. But I'll show you here, 3/8 as well.
Yep. And while you're switching, we got a question here, Tyler. What's the air requirements for PSI and CFM? So, great question. When it comes to PSI, typically we like to tell our customers anywhere from 90 to 120, and then from 20 to 24 CFM. So, great question, Tyler. Thanks for asking.
Yeah, and you see me here, I'm dipping this tap in this cup. This is actually like a gel lubricant, but we also have lubrication options available for these arms. It comes with, especially on our larger arms, it'll come with a flex hose. You may have seen it, that you can just angle towards the tap in the hole, and you just simply spritz the tap with some lubricant with a little lever, small air hose, and that makes it a lot easier for you to use lubricant on this, and maybe easier to remember as well, as you don't always have to dip the tap in a cup. But here, we'll run this for you. Again, no problem for the FlexArm. And before, like I mentioned, these all have a built-in clutch in these. They come set for mild steel, so when you go to tap, a hole in plasma or laser cut hole, it hardens a little bit. So you may experience a little bit of the tap holder clutching out. And that's no worries. All you got to do is adjust that to be a little stiffer and not clutch out quite so early to be able to tap all the way through that hole.
That's a good point. And Logan, obviously you mentioned on the lubrication, so why is it so important to have something either on an automatic basis to ensure that it's happening, especially in plates of this strength? Why is it important?
Yeah, well, I mean, somebody asked a question earlier in reference to the tool life. And obviously it helps tool life, but it also makes it easier on the motor of the tapping arm itself. You're not going to experience as much wear and tear on it. If it cuts easier, it's going to be less work as well. So, yeah, you'll just get a quality cut hole without as much wear and tear on the tap.
And I don't know about you, audience, that's some pretty stuff there. I like it. I like it. So, Logan, obviously we've ripped through laser, we've ripped through the plasma. What are we ripping through next?
Yeah, so we actually do also have a plate cut with a water jet.
Okay, nice.
So, really the benefit too of a water jet over, maybe a plasma or a laser is you don't experience as much hardening because the material is not heated up as much. So, based on the results of the previous ones, there should be no issues with this, but we'll just show you.
Well, check out, we got some B-roll going here of a great example of a water jet running through. Look, some roses, some sharks, some fun creative stuff. So anybody viewing this live stream, this is a fantastic example for those, again, who may not be as familiar with really what is a water jet and how does it work?
Yeah,
Looks
so here
good.
we go. These are 1/4-inch holes. And part of the benefit of the water jet too is these holes have come out a lot more uniform and it's thicker material. So we'll run a couple here. There you go.
Man.
Perfect. And something to mention is, yeah, these are all plates. But if there are parts, maybe not cut out on a water jet or a laser, you can have this tap horizontally. It doesn't always have to be vertical up and down.
Well, hey, Logan, we got Josh coming in with another question. Love it. Thanks again, Josh, for putting up another one. How is the straightness of tapping in the hole? Logan, tell us about it, man.
Yeah, so, I'm going to maybe assume that you mean maybe the tolerance of the tool tapping vertically, and we can hold a plus or minus 2 thou tolerance when tapping these holes. Obviously, if you're tapping a hole that isn't straight up and down, you'll have to compensate for that with our arm, with our multi-position head. We actually have some videos as well on YouTube of that and the changeover. If it's a very obvious hole at an angle, maybe a 45-degree angle, you'll have to line the tapping head up to be perpendicular with that. But I would assume that you're talking about the tolerance of this going up and down, because if this hole is not straight up and down in the material, then obviously you're going to have some issues tapping it in any respect.
We got a good friend, Carl Johnson. How about left-handed tapping? Well, Carl, have we got a product for you?
Yeah, we have that available for sure. And we actually use the same style of tap holders. You would just simply use the tapping arm in reverse instead of forward. And the tap would then spin in reverse and clutch out appropriately. And then you would just have to be conscious of the fact that you're using the reverse button instead of just the forward button to tap in. And two, something that maybe isn't as customary, but in our hydraulic tapping arms, depending on how you wire them, the down button can be up and the up button can be down. So if you're tapping all left-handed thread taps, you can just make it pretty intuitive as far as that goes. So I don't think we've ever had anybody wire a power pack like that on purpose, but we've had people do it on accident. So that's an electrician problem at that point. But
Oh, let's check this out. We got another comment here. It looks good, guys. We upgraded to the hydraulic arms here at Team and Quality Metal Fab. The guys on the floor love them for both large and small tapping. Man, that's what I'm talking about. We appreciate you sharing the love, and hey, we're even showing love to lefties, man. That's what's up. So, no, we definitely appreciate our good friends over there at Teamans. That's awesome. So, Isaac, do we have any other questions you want to pull up for us or for our expert Jason while we're on the stream?
I do actually have a question for Jason.
What's up, man? Let's do it.
So, Jason, on these carts here, and Eddie, I'll have you grab that camera here and show our tap top carts that we love to mount flex arms to make them mobile. But Jason, on cutting holes like this, you know, these are 1/2-inch holes in 1/2-inch material. You know, obviously a laser could do this, and we'll walk you over here to our machine as well. But what kind of maybe issues would you have with a laser versus, you know, drilling these holes with a machine?
Well, so like if you were in a 3/4-inch plate, we used to do jobs from time to time that would call for a smaller tap hole in there. Well, obviously the smaller the hole and the thicker the plate, you're building up more heat. Sometimes you can get slugs that actually burn in and don't actually come out as a hole at all. The advantage to the Flex CNC is going to be obviously the smaller hole and the thicker plate combination. It's going to give you a much rounder hole, much tighter tolerance than any laser plasma. Water jets can also do it. But again, I think your machine is going to be a little quicker in that application. So.
Yeah, too. And something to mention is, you know, obviously on this machine we could set up a handful of these, but we can also do the tapping on this machine as well. We can also do the tapping. So, you know, with a laser or a plasma or a water jet, you would have to take that part off and fixture it to maybe one of our carts or something along those lines. Where on this, you can hit cycle start and it will drill and tap these holes to a pretty tight tolerance. So I know this video is about tapping arms, but that's a good point as far as machining the holes too.
Wonderful, wonderful, solid questions. Isaac, do we have any other questions we want to pull up before we get things wrapped up here? Wonderful, wonderful. Well, that's amazing. So Jason, are there any other comments you want to make based off your expertise to all of our viewers here on the live stream?
No, we have obviously your product on our floor. I've done several demos with it. Definitely love the FlexArm, and seeing the Flex CNC in action is pretty slick too. So.
No, it's amazing, and we thank you all so much really for joining us on the live stream. And then also, Isaac, any other questions that we have? Wonderful, wonderful. So again, thank you so much, Jason, the audience, for checking everything out. We want to make sure, again, you hit that subscribe button, turn on those notifications, give us a huge thumbs up, as well as check out our new revamped website at flexmachinetools.com. And then also, we love making sure we're keeping you up to date on our live stream. So our next one, we're going to be doing a little bit of fanciness here. So you are going to be able to find out what these two things have in common. If I get this bad boy going, here we are. All right, well, it's a blowtorch. Nonetheless, what we're going to be doing flow drilling. For the guy who can't figure out the blowtorch, we got it. So nonetheless, we're going to be doing flow drilling with the largest flow drill in the world. So make sure you join us again. That is next Friday. We'll make sure to keep you in the loop with the information. If you hit that notifications button, we'll even be able to do a better job of keeping you in that loop. So with that, thank you all for joining us. Stay awesome, stay flexing, and we will see you next time.
Thanks, guys.